My name's Ty.
My name's Sarah.
Welcome to the AP Calc BC 2008 Form B question number 4. FRQ.
Let f be the function given by f of x is equal to kx squared minus x cubed, where k is a positive constant. Let R be the region in quadrant 1 by the bounded by the graph of f in the x-axis. Part A says find all values of the constant k for which the area of R equals 2. First, you can factor out an x squared, which will give you x squared times k minus x. Then you set it equal to 0 to find the point in which it passes through the x-axis, which you find is at 0 and some point k. So your graph could look like this, or it could look like this. It doesn't really matter, but it has to pass through 0 and some point k. Then you can write the integral as the integral from 0 to k of the equation, which is kx squared minus x cubed dx.
So once you integrate this, you would get kx to the third over 3 minus x to the fourth over 4. And you would plug in your bounds, which are 0 and k. And you know if you plug in 0, you would just get 0. So you get k times k to the third divided by 3 minus k to the fourth divided by 4. And if you simplify that further, you get k to the fourth divided by 3 minus k to the fourth divided by 4. And then you need to get a common denominator, which would come down here and give you 4k to the fourth minus 3k to the fourth, and this is all divided by 12, which is your common denominator. Further simplifying it, you would get k to the fourth divided by 12, and remember that we want to find where it's equal to 2, so we go back and set it equal to 2. Now I would cross multiply and get k to the fourth is equal to 24, and then you can take the fourth root, so you get k is equal to the fourth root of 24 as your final answer for part A.
Part B says for k is greater than 0, write but do not evaluate an expression in terms of k for the volume of a solid generated by rotating R about the x-axis. So the formula for volume of a solid is pi times the integral from a to b of f of x, which is the top curve, minus g of x, which is the bottom curve, squared dx. So if you remember the graph, you have 2 points at 0 and at k. If you draw a little rectangle in, you can see that the top curve is kx squared minus x cubed, and the bottom curve is just x-axis, which is 0. So the integral you write is pi times the integral from 0 to k of the curve, which is kx squared minus x cubed, and it'd be minus 0 since that's the x-axis, but you don't need to write that, and then squared dx.
For part C, it says for k is greater than 0, write but do not evaluate an expression in terms of k involving one or more integrals that gives the perimeter of R. So if we draw the picture again for a visual, we know it's from 0 to some point k, and here's the thing. We know that this part would just be k, and this right here would be arc length. So we know that the formula for arc length is the integral from a to b of the square root of 1 plus the derivative of x squared dx. So first I'm going to take the derivative. So f of x is equal to kx squared minus x cubed. So then it'd be 2kx minus 3x squared. So now I'm going to plug in my information. We have k, this part right here, plus the integral from 0 to k of the square root of 1 plus 2kx minus 3x squared, all squared, dx. And here's the formula to give you perimeter.